Let's talk a little bit more about properties of exponents. So we've already talked about what happens when you have a zero exponent, what happens when you have a negative exponent. In this video, we're going to be talking about what happens if you have the product of powers, the quotient of powers, and what happens if you have a power raised to a second exponent. So first, we'll talk about product of powers, and that just means you've got two different pieces. They have the same base, and they each have an exponent. So what we can do then is just add the exponents. And here's basically why. Let's say I've got 5 to the power of 2 times 5 to the power of 3. The claim is that since I have the same base, they both have a base of 5, I could just say that this is actually just 5 to the power of 5. I just take those two exponents, 2 and 3, and I add them up. But the reason that this works is because everything is really just multiplication. 5 squared is just 5 times 5, and 5 cubed is 5 times 5 times 5. So if I have 5 times 5 times 5 times 5 times 5, that's just going to be 5 to the 5th power. So we're just counting how many times we're multiplying out the number 5. Quotient of powers has a very similar relationship, except now you're dividing two powers, and so you're going to reduce. So this says if I have the same base in the numerator and the denominator of a fraction, I can just simplify by subtracting those exponents. So notice that we have m on the top, n on the bottom, and then we just subtracted them to get our new exponent of m minus n. So if I go back to using my 5s again, just like I did in the last example, let's say I have 5 to the power of 5, and I'm dividing that by 5 to the power of 3. Well, what this really means is that I have 5 5s in the numerator, and I'm just multiplying them all out. In the denominator, I have 3 of them. When we're reducing fractions, we're just looking for matching factors on the top and the bottom. But I see that happening a lot here. I've got a 5 on the top and the bottom, so I can go ahead and reduce those. A second pair of 5s that I can reduce, and then this third pair of 5s that I can reduce. So what I'm left with is just 5 times 5 in the numerator, or 5 squared. And then since there's nothing in the denominator, I could write it as over 1, but I don't need to. I could just leave it as 5 squared. So a more simple way to do that would be to say, all right, well, I have 5 5s on the top and 3 5s on the bottom. I know that all 3 from the bottom are going to cancel out with 3 of the 5s on the top. So let me just take those 3 5s and reduce them on the top, and then I subtract 5 minus 3 to get 5 squared. It also works if the larger exponent is in the denominator. So let me show you what that would look like. If you have your larger exponent in the denominator, so maybe I have 5 to the 3rd over 5 to the power of 5. Remember that this just means a bunch of 5s on top and a bunch of 5s on the bottom, all multiplied. And I'm going to reduce them. So on the top, I see a 5 with a matching 5 in the denominator. Those reduce. Here's a second pair that reduce and a third pair that reduce. But now notice that there's no more 5s on the top. All of the 5s from the numerator canceled. So really there's a hidden 1 here that allows me to fill in my numerator with a 1, and then I have 5 times 5, or 5 squared, in the denominator. So it's the same thing, but now I have the reciprocal of what I had before, and here's why. What I did is I said, okay, there's actually more 5s in the denominator this time. So I know that when I go cancel things out, I'm going to have more 5s left on the denominator. So let me cancel everything from the top, leaving me with just a 1, and let me cancel 3 of the 5s from the denominator. So since I have more in the denominator, I'm moving the smaller number down, leaving me with 1 over 5 to the power of 5 minus 3, or 1 over 5 squared. So you really want to start with the larger exponent and bring the smaller one to wherever the larger exponent is, whether it's on the top or the bottom. The last one we'll talk about is when you have a power of powers. So this says you have a base with an exponent, and then you have another exponent on that. What we do is we just multiply the two together. So m and n were both exponents. We just multiply them to get our new exponent. So if I have, for example, 5 to the power of 2, and I'm raising that to the power of 3, then this would just become 5 to the power of 2 times 3, or 5 to the power of 6. And here's why. If I look at 5 to the power of 2 as my base, that is being raised to the power of 3. So I would have 5 squared multiplied by 5 squared 3 times. And then we can use our very first property from today, where if you're multiplying but everything has the same base, then let's just add up those exponents. So 2 plus 2 plus 2, and that would give me 5 to the power of 6. So when you have a power on a power, you are just multiplying, because essentially you're just adding that number over and over and over. So when you have a power on a power, we just multiply those two exponents. Okay, so let's put it all together and do a few examples. I'm going to simplify these three. They're kind of more basic. And then the next slide, I've got a few questions with some more going on. In number 1, I see that there is the same base of 10 and we are multiplying those two bases. So all I'm going to do is take my exponents and add them. So this would be 10 to the power of 3 plus 4 or 10 to the power of 7. And that's all I need to do to simplify. I don't need to multiply it out. Number 2, I have division between two bases, 7 and 7. They match. So I'm going to find the higher exponent and bring the smaller one up to be with that greater one. The smaller one is my 7 squared. So I reduce all of that, leaving me with a 1, and I subtract 2 of the 7s from the numerator. So instead of 9 7s, I'm taking 2 of them away, and I have 9 minus 2, or 7. So I have 7 to the power of 7. And again, we're not going to multiply that out. The last one is a power raised to a power. So I'm going to multiply these two. 2 to the power of 4 times 3 gives me 2 to the power of 12. Our last few are going to have a little bit more going on. We might even need to use more than one rule for some of these. So number 1, when I'm looking at my fraction, the first thing I'm thinking is, can I reduce my coefficients at all? 3 and 2, I can't reduce those. So now I'm going to look at the x's. They have a common base, and because everything is being multiplied, I can go ahead and apply that quotient rule where I reduce all of the x's from the denominator and I reduce them from the numerator as well. So in the numerator, I have 3 times x to the power of 5 minus 2. And in the denominator, all the x's canceled, but I still have my 2 there. So this would be all over 2. So 3x to the power of 3 all over 2. And that would be as simple as you can get. Number 2, just follow your order of operations, which says do inside of any grouping symbols first. So I'll simplify those 4s. When I do that, I add the exponents together to get 4 to the power of 6, and then all of that's raised to the power of 3. Now I have the power of powers, so I'm going to multiply the 6 and the 3 to get 4 to the power of 18. And then last, I'm going to look at the coefficients. I see 5 and 10, and I can reduce these just like I would if they were in their own fraction. So 5 will reduce down to a 1, and 10 will reduce down to a 2. So I've got 1x squared y to the 6 in the denominator, 2y to the 9th. Now I'm going to look at the x's and the y's and see if I can reduce those. The x doesn't reduce with anything in the denominator, but my y's will reduce. Notice that there's more y's on the bottom this time. So I'm going to take all of the y's from the numerator and reduce them. And then from my 9 y's on the bottom, I'm going to cancel out 6 of them. So on the top, I've got 1x squared, and in the denominator, I have 2y to the 3rd. You don't have to write that coefficient on x. You could just leave it x squared over 2y to the 3rd if you wanted to, but that's up to you. So either way, this would be our simplified form. So I hope that helped. Thanks so much for watching, and I'll see you next time. Bye.